Let's wrap up our coverage of the immune system by talking about some disorders. One thing you hear people talking about a lot is allergies. I bet a lot of you have allergies. Let's talk about what does an allergy mean, all right? Well, excessive immune reaction against antigens that most people tolerate. Allergens, we call them. So, a lot of people can go outside and walk around outside and there's pollen out there and they don't mind a bit. Other people, oh God, it makes you sneeze and cough and makes your eyes water. That's what allergy is. So these are antigens, all right, that most people don't have a problem with, but some people do. We call them allergens. That's what an allergy is. They're classified by the time course. So acute or immediate reactions begin within 30 seconds and last maybe up to 30 minutes. This can be reactions to things like, latex and, perfumes and stuff like that, where you might get a rash, but usually it goes away pretty quickly. And then delayed, these are 1 to 3 days, may last indefinitely. These are the classic, like pollen allergies or, dander and stuff like that, where you basically just day to day, you're just miserable. You always got the whole coughing, sneezing, runny sinuses, eyes, and so on, all right? And we can classify them by immune system involvement. So acute reactions are antibody mediated, whereas the delayed are T cell related, all right? So there you go. That's what's going on. And you see a little kid there, sorry you was allergic to me. I brought you some tissues, okay? But that's what's going on. It's just a matter of the antibodies and the T cells of you not tolerating something that, is going to end up bothering you. Your immune system reacts, all right? And other hypersensitivity reactions, in general, we can talk about a type 1, the antibody-mediated, the IgE. Remember IgEs were the ones on basophils and mast cells? These are the acute reactions. These are the bing, bang, boom. These are most allergies. So asthma, food allergies, bee stings, hives, penicillin, latex, etc. These are local or systemic. Systemic ones, may cause a localized rash, irritation, whatever. Local will cause that. Systemic means your whole immune system, your whole body gets involved. There can be massive histamine release resulting in anaphylactic shock. So that's like the bee sting allergies, the walnut allergies and stuff like that. You get exposed to those, the IgEs on the basophils and the mast cells respond, huge release of histamine, vasodilation, PVR goes way down, mean arterial pressure goes way down, and you're not pumping blood to your body at this point, and so this is potentially life-threatening. Then type 4, cell-mediated T cells, these are the delayed. These are the cosmetics, poison ivy, TB tests, skin graft rejection, Crohn's disease, type 1 diabetes mellitus, rheumatoid arthritis, multiple sclerosis. The classification of things as whether or not they're type 1, type 4. There's also type 2 and type 3. I didn't bother to put them in because it's often not clear what things are. There's a lot of controversy in this area, a lot of differing opinions on what exactly constitutes what. I'm just going for type 1 and type 4, okay? Not even going to mention 2 and 3. What I would like you to know is that type 1 are the immediate reactions. Those are antibodies. Type 4 are the delayed. Those are T cells, okay? If you know that, you're in good shape. And the exact classification of any hypersensitivity reaction is not really clear. So let's talk about then autoimmune diseases. Autoimmune diseases are one in which your immune system overreacts. In other words, it's like your immune system is too strong. It's causing too much of a response, which is bad. Remember homeostasis. You want your immune system to respond, but you don't want it to over-respond. That in itself is bad. So this is a failure of self-tolerance. Can be anyway. Remember we talked about how when the B cells and T cells went through training, they had to go through positive and negative selection. Don't shoot the girl with the lollipop. Autoimmune diseases can be situations in which your immune system is trying to shoot that girl with the lollipop. That's not good, all right? So this can come about through what's called cross-reactivity. Some antibodies respond to self-antigens. So normally antibodies that are only supposed to attack foreign invaders, instead something goes wrong and they start going after your own self-antigens. Remember self-antigens like the markers on the blood cells, the red blood cells, type A blood, type B, I got that Rona. But there are lots of self-antigens in your body. And normally this is what the T and B cells were trained not to respond to. Sometimes it goes wrong, and that's what happens. Abnormal exposure of self-antigens, a breakdown of internal barriers. So sometimes, fluids that should be kept in different compartments, for some reason the barrier breaks down and you get antibodies released into areas where they shouldn't be, all right? So abnormal exposure of your self-antigens is something that they shouldn't normally see. Changes in the structure of self-antigens, so viruses, drugs, other kinds of things can cause your self-antigens to mutate. And so antibodies normally wouldn't bother them, but once they mutate, then they become susceptible to a response from your antibodies. So you can also, failure of self-tolerance is one cause of autoimmune diseases. Another is production of autoantibodies that attack your body's own tissue. This is where you basically incorrectly make antibodies against your own tissues, all right? The autoimmune status of diseases often disputed, not always agreement whether they are or not. So, but one way or another, what you end up with is you end up with antibodies that are attacking your own body, and that's bad. And T cells and B cells as well. So like you see in the upper illustration there, rheumatoid arthritis, that's where your immune system attacks the connective tissue in your joints. Multiple sclerosis, that's where your immune system attacks your myelin sheaths. Type 1 diabetes, your immune system attacks the beta cells in your pancreas. And inflammatory bowel disease, where your immune system attacks tissue in your intestines. This doesn't mean, by the way, in the lower left, it doesn't mean antibodies that attach to cars. That's not autoimmunity. Autoimmunity means, immune to your own things. And you can see in the lower right then, what triggers these autoimmune diseases? This is the complicated part. There seem to be a lot of factors involved. Part of it is genetic, part of it is just your environment, and then part of it is just your immune system regulation, all right, whether things are working correctly in your immune system or not. So all three of these things can influence each other. They can all come together, combined, and cause autoimmune diseases. Autoimmune diseases are complicated. A lot of them are not well understood. And we still don't even really agree on which things are and are not autoimmune. Some of the ones that we tend to agree on, rheumatoid arthritis, again, this is where you attack mostly synovial joints. Multiple sclerosis, attacking the myelin sheaths on neurons. Myasthenia gravis, you may have learned about this in Bio 201. That's where we attack acetylcholine receptors at the neuromuscular junction, so you get a muscle weakness. Systemic lupus erythematosus, people usually just call it lupus. It's an inflammatory disorder of connective tissues all throughout your body, connective epithelial tissues, so you get inflammation of heart, lungs, joints, skin, liver, etc. Type 1 diabetes, beta cells in the pancreas get attacked by the immune system. Crohn's disease and inflammation of the GI tract. Psoriasis, this is where you simply start making too many keratinocytes. They get itchy, they get scaly. In the lower left, you see the typical butterfly of lupus. All right, so again, there's some controversy with which things are and are not autoimmune, but those are pretty thoroughly agreed on. In every one of these cases, you've got your immune system just going wonky, and so things go out of control. Now, those were the overreaction. Those are autoimmune disorders. Those are where the immune system overreacts. There are also what are called the opposite end of the galaxy, opposite end of the spectrum. These are immunodeficiency diseases. This is where your immune system underreacts. So in autoimmune disorders, your immune system was too powerful. In immunodeficiency, your immune system is too weak. So the classic one here, severe combined immunodeficiency disease, SCID. This is where you were born without T or B cells. Imagine if you were born without T or B cells, you have no specific immune system. You can't train them to fight things, and therefore you're always susceptible. You're never going to have immunity. Remember, immunity means having the memory cells and the antibodies. Well, you're not ever going to have those. Therefore, you can never become immune to anything at all. So you're just vulnerable to all kinds of infections that normally wouldn't bother other people. You can't ever train your immune system against them, and so you're susceptible to everything out there. The bubble boy was the classic one back in the 70s. There was a kid born with this, And he became well known because NASA, he had to live basically inside of a plastic tent his whole life. He couldn't be exposed to anything that might get inside of his body. So NASA actually made him a special suit that allowed him to go outside for the first time ever. Now, how do you suppose you could fix SCID? What could you do? If you have hereditary, if you don't have T and B cells, what would be the only way to get them? Remember, remember T and B cells, are you remembering now what they actually are? They're T and B lymphocytes, they're white blood cells. Where are all blood cells made? In the red bone marrow. So how could you fix this? By getting a bone marrow transplant. Of course, the problem is that you have to find somebody who's compatible, all right? And there's also a risk with the operation. That's what they tried to do for the bubble boy. They tried to give him a bone marrow transplant from his sister, and somehow during that whole process, he got an infection and he died from it. So they did the best they could, but there's just not much you can do when somebody's immune system is too weak to fight anything at all. And that's the one that you're born with. So there's also acquired immunodeficiency syndrome, AIDS, or AIDS, as everybody knows it. This is where you get infected with the human immunodeficiency virus, HIV. It invades T helper cells and macrophages. So think about this. Remember the T helper cells were at the very core of your immune system. That's where remember the APCs would ingest the antigen, they would present it to a T helper cell, and then the T helper cell caused the cloning of the T and the B cells to make the plasma cells, to get the antibodies, to make the cytotoxic T cells, and so on. So AIDS, HIV, the virus, attacks T helper cells. So if you attack T helper cells, what do? You shut down the entire damn specific or adaptive immune system. And so, once again, it's not actually the virus that kills people with AIDS. What kills people with AIDS is they have no immune system. Their T helper cells can't function to activate their specific or adaptive immune system. Therefore, they are susceptible to everything in the damn world. And that's how they first really discovered AIDS. They suddenly had people dying from things that nobody had died from in decades. These weird diseases that are out there, but most of us have no problem fighting them off. But if you got HIV, you can't fight them off. So these are retroviruses that synthesize DNA from RNA. New DNA is inserted into your host cells. It can lie dormant for 10 years or more. That's the problem with AIDS. You might even not know you have it, and that's the problem there, is that you can be out infecting other people, not knowing that you are infected. Transmitted through blood, semen, breast milk, vaginal secretions, documented transmission by oral sex. So there's really no safe way to do this if you got AIDS, okay? Can cross the placenta. Unfortunately, you have babies born with AIDS. Boy, what a sentence that is, huh? And so you're susceptible to many opportunistic infections. There are, and I don't keep up with this. When I made this PowerPoint 4 or 5 years ago, there were currently like 16 anti-HIV drugs. I don't know how many there are, but the poor AIDS patients, man, like they're taking drugs all day long to try to help the fact that they have no T helper cells. That's why AIDS patients are always looking at their T cell counts. You hear AIDS patients talk about, what are your T cell counts today? They're usually talking about T helper cells. And a nice little diagram here showing kind of like the 4 possible conditions or categories, situations. So you have either internal threats or you have external threats. You have either your immune system overreacts or your immune system underreacts. So autoimmune, that's where the threat comes from inside and your immune system overreacts. On the other hand, when it comes from inside and your immune system underreacts, that's an example of cancer, along with hepatitis, HIV, shingles, things like that. Then external threats, if you overreact, that's what an allergy is. If you underreact, that's an infection. That's where, for whatever reason, your immune system doesn't succeed in fighting it off. That's where, the pathogens overwhelm your immune system. They win the battles, and so you get an infection, all right? Good diagram there. Really sums it all up. Okay, so which of the statements below is false? Natural killer cells respond to the stem of the antibody. Type 1 hypersensitivity reactions are mediated by antibodies. Measles vaccine is an example of artificial active immunity. IgE is responsible for most allergies. AIDS is an autoimmune disorder. Which one of those is wrong? Yeah, AIDS is the opposite of an autoimmune disorder. AIDS is an immunodeficiency disorder. Autoimmune is where your immune system is too strong. AIDS is where your immune system is too weak. They're on opposite ends of the galaxy, okay? And there you go, the best way to strengthen your child's immune system. This is what's supposed to happen. Remember, it's during childhood that your T and B cells are getting trained. This is where you need to expose yourself to all the muck and the guck and the goo and the grime and the slime and all that crap out in the world so you can train your immune system, all right? Now, little kids should not be playing in raw sewage and inhaling paint thinner and stuff like that. But it's perfectly natural for little kids to go outside and get dirty and to lick dogs and roll in the mud and stuff like that. Yes, they're building their immune system. This is what a healthy child looks like. This is the way kids are supposed to look. And there's good data at this point. The parents, I see these ads on TV, it's just horrifying. You see little kids playing together, one of them sneezes and mom goes running for the Lysol spray and the Clorox wipes and stuff like that. Oh my God. There's good evidence at this point that parents who overprotect their kids, those are the kids who end up with allergies and asthma and so on. Those are the kids whose immune systems don't develop correctly because they're not getting exposed to the world like they should. So let your kids be kids, okay? That's healthy. That's normal.